Good morning, good afternoon, and good evening, whoever you might be joining from. I am HR Funk, and this is HR's Firing Line. And this is the online show completely dedicated to firearms and driven by all of your questions, comments, and suggestions. Because without them, I would be sitting here wondering why I was staring at myself on a computer screen with nothing going on. I see we've already got quite a few people in here. In fact, according to the ticker over here, we've got 11 people so far. Elaine's Domain made it back. Glad you made it, ED. Albert Michael, Paul I always have a hard time saying this. Puglia, Art Grote, Bill 1717, and I know I saw the artist formerly known as ERJG 1954 was in here. Rabbi is here. Glad you made it, Rabbi. So we got a lot of the regulars here, and hopefully we'll get some more coming in soon. And I don't think I said it. This is the Thursday, March 7th, 2024 edition of the Firing Line. And by the way, I apologize for having to move things back a day. I know a lot of you just got done watching what normally would be the Wednesday premiere video, but I had an unavoidable obligation yesterday, and I wanted to be sure to be here for that, and also to be able to start the live stream more or less immediately after the video ended. So for any of you that it made it difficult or inconvenient, I apologize. And if some of you just were not able to watch today, at least hopefully you'll be able to enjoy the replay. I do have a guest with me here today. Some of you already know that. Jeremy Kahn from Control Solutions is going to be here. And if you saw this morning's video, you know that I was featuring muzzle brakes that he produces in that video. And I have found them to be a very helpful item on my rifles. And I was just talking to Jeremy before the show started. And I said that I used to kind of think of muzzle brakes as being, I don't know, kind of a gimmick or at very least something for rifles that were much more powerful than those that I typically shoot. You know, with me shooting in the 556, 308, 30-06 type of rifle range, if you will. I just didn't know that they were going to add that much. And then years ago, I went to the course at Bang Steel, Forest at Bang Steel, added the muzzle brake to my rifle after we'd already been doing some shooting. And all of a sudden, shooting at those long distances, I noticed my sight picture staying much more stable on target than it was before. And all of a sudden, I was able to see those shots hit, or impact rather, at the long range. And I could more or less instantly apply any correction I needed to my hold in order to get a follow-up shot on target. So that started to make me a believer. And then Jeremy was kind enough to send me the muzzle brakes that were used in today's video. And I was able to do some more experimentation with them. And the more I use them, the more I like them. So I am so happy to have Jeremy here. I talked to him a couple of weeks ago, and we had a long conversation about muzzle brakes and ballistics and rifles and basically all things applicable to shooting. So I am happy to have him back as a guest, and I'm going to get right into bringing him on the show. By the way, for those of you watching, as we go through, if I see questions that you're posing or comments or whatever, I can present them to Jeremy. So this is your chance. If you have any questions relating to muzzle brakes, rifles, ballistics, or whatever, be sure to throw those up because I can send them right over here to Jeremy, who is our expert. And thank you, Jeremy, for joining today. You are now up on the screen where everybody can see you. And I know
Good morning,
you said
Howard. Good morning, everybody.
Down there in North Carolina?
Oh, yeah. We're supposed to be in the 70s today.
All right. We'll be lucky if we break 50 here. I don't know what the weather forecast is for today. It's probably in the low 40s at the moment and fairly gloomy outside. I think something that I have not asked you before that might be of interest as we kick things off here. How'd you get into the muzzle brake business? I mean, that doesn't seem like something you wake up one day and think, I think I want to start to produce muzzle brakes. So how did that come about?
Well, at the time I was working as a machinist, and I was doing a lot of shooting myself, and was looking at ways to make myself a better shooter. I typically, at the time, was more into the hunting scene, and doing a lot of varmint hunting, I was getting a little bit frustrated breaking the shot on a critter and then losing sight picture and then not realizing whether the critter went down in the weeds or if I missed and it ran off. Um, so I started researching muzzle brakes and studying the science of why muzzle brakes work. And one of the things I came to the conclusion of is at the time, which was about 14 years ago, the majority of the muzzle brakes that existed um, seemed like they were designed by marketing guys instead of actual scientists or engineers. Um, and I knew enough about physics to understand that what most muzzle brakes were doing was only half the story. As far as they were running off of a false assumption that a lot of people to this day still follow, is that a muzzle brake works off of almost like jet propulsion, when a muzzle brake works more like a parachute. You see a lot of the brakes back then and even now with the ports that angle backwards. Well, you're not dealing with a steady stream of gas. You're literally dealing with a fixed volume of gas that's moving one direction. So uh, when you change the direction of it and make it blow backwards, it's not actually providing any thrust forwards. The thrust comes from the actual gases impacting the brake itself. So one of the things I started looking at and doing some high-speed video and Schlieren photography of was that a lot of these brakes that had the rearward-facing ports, they would develop what we call stagnant airflow. So basically, the gases go into the first chamber of the brake, and then they literally come to a screeching halt. But then they create this pocket of really compressed air that forces the remaining gases to just exit without actually impacting the brake. So we started playing with does there need to be any angle, or as a straight 90-degree baffle the best way to go? And through probably 30 or 40 iterations of angles and directional type things, we through our testing we found that 90-degree baffles are the most efficient, just because of the fact when the gases are exiting the barrel, they're not coming out straight forward. The bullet's in the way, so the gases are always going to be exiting at an angle that's not in line with the barrel. They're going to be coming off of an angle. So when they impact the 90-degree baffle, they actually go outwards after the impact instead of stacking up within the brake.
And that's something I'm glad you said that, because that's something that I was confused about. In fact, I made that mistake in my video today. And in my mind, I think I always was envisioning those brakes that were on the Barrett 50s. And I think they
Right.
still are, that angle to the back. And I was thinking the same thing you just said. It was jetting or venting that gas rearward, pulling forward on the barrel to slow the rearward motion of the rifle.
And
But
now, and I'm glad you brought that up, because up until the late 90s or even the early 2000s, the only brakes that really existed were on tanks or artillery. And in the grand scheme of things, 50 BMG is actually closer to an artillery round than a what we call small arms cartridge. um, there, those work with angled baffles because there's so much unburnt powder in a 50 BMG that they're not actually harnessing the gases. They're literally harnessing the explosion of the unburnt gases when they exit the end of the barrel. So those, in a sense, do work off the principle of jet propulsion or rocket propulsion. But in small arms, there's not enough unburnt powder to create that explosive effect that would actually create thrust.
and that's I'm glad you differentiated that. So with your brake and with the 90-degree brake, the idea is that volume of gas is coming forward and impacting the 90-degree baffle, And like you said, it's acting like a parachute as the rifle tries to move rearward. It's working against that gas. Now, I'm assuming the multi-chambers in your brake basically multiplies that effect through each chamber. Is that correct?
It doesn't multiply effect. Probably 80% of the work, at least on our brakes, 80% of the work is performed in the first chamber. Um, the second and third, and you'll see a lot of brakes with multiple baffles, and typically they tend to be the angled baffles. But on ours, if you if you look at your work rifle that you fired many rounds through, and you can see blast patterns on the baffles. If you look at the one closest to the muzzle, and then the next one, and then the one closest to the end where the bullet exits, you'll notice that the blast pattern is increasingly smaller. So if we added another port you, or another baffle, it'd probably make next to zero difference.
Okay. And I think you told me the gases that are coming out of or I'm doing a poor job of explaining it. The gases that are propelling the bullet down bore are equal to the weight of the powder that was originally in the cartridge, but they're
Correct.
moving considerably faster than the bullet when they exit the muzzle. Is that correct?
That is correct. And that just goes back to I don't want to say basic physics, but you can't destroy something. You can only change its form. So just like water, you've got ice, then you've got water, and then you've got steam. Well, a gallon of water turns into a gallon of steam, and that gallon of or that excuse me, a gallon of water is 8 pounds. You turn that 8 pounds of water into steam, it still weighs 8 pounds, but it's going to take up an area the size of a house. So gunpowder is much the same way. When you convert it from a powder to a gas through combustion, all of the mass is still there. You can't the mass doesn't go away. The mass still exists and it still weighs the same. It's just much larger. So because of the superheated air, this is another one of those geeky physics things. Things especially gases, will not travel faster than their given Mach number. And Mach number, a lot of people think of it as solid objects, speed of sound. Well, the higher the air temperature, the faster you can make something go before it reaches Mach. Mach is when it basically goes faster than the ability of the shock wave to get out of its way. So, with superheated gases, such as those coming out the end of a rifle, the gases are so hot, they're literally moving 3 times faster than the bullet once the bullet uncorks, which is one of the reasons, if you're familiar with the old school chronographs, you had to put the chronograph 10 feet, a minimum 10 feet from the muzzle. Otherwise, you were going to be measuring the velocity of the gases because the gases would get there before the break or the bullet would.
So is it accurate to say that the gas reaches the first baffle of the brake before the bullet does? Is that correct?
Um, Depending on how long the port is. And that's that. And there's a lot that goes into our brakes as far as the dimension of the port, front to rear, as far as in between baffles. Um, Theoretically, if the bullet was, say, the shape of a wad cutter, the gases would. But because the bullet is cone shaped, the nose of the bullet is actually going through the first baffle by the time the base of the bullet exits the muzzle.
Okay, I understand.
But theoretically, yes. And that's one of the reasons why a lot of people talk about caliber specific muzzle brakes, and that's actually an old wives' tale. Because when you study blast patterns and the flow patterns of the gases, um, anything smaller, at least with our dimensions, any hole smaller than 1.6 times the bullet diameter is literally just excess material for no reason, because the bullet creates a blast shadow. So the gases are coming out at such a high rate of speed that they go around the bullet, but they don't go out and then back in. Once they change directions, they maintain that direction.
That makes sense. I understand that. So, wow.
Unless they're acted on by something else like angled baffles. And
Now,
that, go ahead.
something I don't understand, and I hope you can help me with this, is, and I tried to explain this in the video, I probably did an awful job, but as the bullet is exiting the muzzle and the blast pattern or the gas is starting to move past it and expand, there's a stabilizing effect that has on the bullet to, at least in theory, increase accuracy. Can you explain that at all? Can you make that
Uh,
make sense to me?
yeah, because in shooting a non-braked rifle, and you see this a lot with, um, we believe it or not, sell a lot of muzzle brakes for 22 competitors, just because of the fact it cleans up the airflow. The gases are moving fast enough that when they pass the bullet, and say, as opposed to the half an inch in the inside the muzzle brake, when you shoot around, the gases will go around the bullet, but then the gases are continuing to expand slightly at that point, and it creates a lot of what we call dirty air. So one of the reasons muzzle brakes increase accuracy, or at least some muzzle brakes increase accuracy, is it's stripping all of that dirty gas away from the flight path of the bullet, so the bullet is traveling through clean air and isn't being disturbed by dirty gases. Which brings me up to a point I almost made a minute ago. When you're dealing with a lot of these brakes that have the angled ports and things like that, the the gases, they exit the muzzle, they go outwards to go around the bullet, because the bullet's in the way, and then if you have an angled baffle, they're actually being redirected back into the path of the bullet. So it's not uncommon to see some rifles actually lose accuracy because of um, inefficiently designed brakes, that because they think they're redirecting the gases backwards to create thrust, what they're actually doing is they're sending the gases back into the path of the bullet. And if you ever watch any slow motion video of different styles of brakes, you'll see that a lot of the ones with angle baffles have way more gas coming out through the bullet hole than our brakes. If you and I think you actually shared one of the pictures off of our website, that you literally see the flash of the bullet coming. It was caught by the sunlight. You see the bullet, but you see there's no air or no gases coming out through the bullet hole, which
And
tells us that the brake's done as much as it can do.
and I actually have that photo on my computer screen. I was trying to figure out if there was a way that I could bring that on here so people could see it, and I can't figure out how to do it. I wish I could, because I think that's great. You can actually see how that gas is impacting the baffle on the brake, and like you said, you see the bullet itself that is, exited and is moving down range. But
And there's clean air.
yeah, so I mean, and as you explain that, I'm visualizing that in my mind. So uh, any of you that are wondering what we're talking about, if you go to the Control Solutions website, there's a scrolling photo at the top, and one of those photos that comes up is this photo we're talking about, where you can see the gas impacting that baffle. You can see the path of the bullet leaving, and it really gives you a great understanding of exactly what we're talking about here. I wish I could show it for everyone on the stream here. Um, Along with that accuracy enhancement, also we have the effect of the brake just physically, or the mass of the brake being attached to the muzzle of the rifle. And I did talk about this in the video, stabilizing that muzzle somewhat with regard to the barrel harmonics. Um,
Yeah.
Do you see? Is there any sort of a rule of thumb or a typical amount that you see with regard to increasing the accuracy from that effect, along with the clean air that is being created by the brake?
Um, it's not quantifiable because it so much of it depends on the rifle itself, how free floated the barrel is, how long the barrel is. Um, but there is definitely, anytime you can add a fixed mass to the muzzle of the barrel, it's going to affect things. Typically in a good way. One of the things that's come up in the precision rifle series and those type of disciplines is they're actually running barrel tuners, which is basically a weight that's adjustable, and it screws in and out to control the length, so that you're changing the position of the mass on the end of your barrel, so that you can actually fine tune your barrel to the load instead of having to fine tune your load to the barrel.
I remember years ago, I think it was Browning that had the barrel optimizing system on the end of the barrel that basically did that. You could screw it in one way or the other
Yep.
way, and it would make it a little bit longer and a little bit shorter, with the idea of tuning those barrel harmonics. So that sounds like more or less the same thing you're describing here.
It is. Um, and when we first started making, because we initially started just making the clamp on brakes, because that was a market that had not been touched by any of the muzzle brake or muzzle device companies at that point 14 years ago. Um, I had some guys who were shooting F class type disciplines where in competition they weren't able to use muzzle brakes, but in practice they would use the muzzle brakes just so they didn't wear their shoulder out shooting hundreds and hundreds of rounds daily or multiple times a week. And they were seeing a significant shrinkage in their group size. Um, so we started playing around with trying to figure out why it was. Was it just the gases? Was it the increasing the structural integrity of the muzzle, which I'll get to in a minute, or was it the just the mass of the brake? So we literally, for testing, we took one of the clamp-on muzzle brakes, clamped it on, and then literally hacksawed all the baffles off of it. So they basically it just became a, a clamp-on weight, and the a lot of the accuracy improvement was still there. Um, and some of that did have to do with the weight, but something else we've actually found through the years is that with clamp-on brakes as opposed to threaded brakes, the clamp-on brakes actually add structural integrity to the muzzle of the rifle. Um, Even on relatively, say, magnum caliber or magnum profile barrels, which is what the Remingtons typically are, um, as the bullet exits, the barrel is the muzzle swells as the bullet exits, so you don't get as tight of a fit as the bullet exits. So you clamp the muzzle brake on, and all of a sudden, it's not swelling as much, and the accuracy is increasing there as well.
As you describe that, I'm thinking of the old Elmer Fudd cartoons where he would shoot and you would see the barrel bulge as the shot was moving down the barrel, and all of a sudden, it would come out the muzzle. But that's what
Oh
I'm
yeah,
envisioning, and basically what you're saying is that actually does take place, but obviously it would be at a probably
yeah,
microscopic level.
yeah. It is a microscopic level, and typically has to be measured using strain gauges, um, which is one of the ways they measure chamber pressure and receivers and that type of thing. It's basically a gauge that is glued to the barrel, and as the pressure swells the chamber, it causes that strain gauge to create an electrical current, so they can actually measure how much swelling there is.
Hmm.
And you can see the same swelling at the muzzle if you do one of the strain gauges around the end of the muzzle. So yeah, the the barrel definitely does the Elmer Fudd, just not to that scale.
Um, I want to get into one other thing, and then I want to start looking over here to see if I can get some of the comments from the folks that are watching. But you've got the one break. Uh, actually, I just lied. I'm going to ask you two more things. The first one is regard to the muzzle brakes on the AR rifles, and I put one on my little AR SBR, and I just thought it was really interesting. Once again, how stable the sight picture stays, and I was even able to show the side by side with and without the brake or the yeah, muzzle brake installed. Um, when you see that on the AR systems, I mean, we're not talking about a heavily recoiling cartridge to begin with. Um, do you get a lot of feedback from competitors with regard to that stabilizing effect, or how much more quickly they are able to put shots on target?
Oh, absolutely. We're actually one of the one of the most effective breaks in the three gun competition series. We've got professional shooters shooting for all different rifle companies that are running our breaks, just because of the fact that when they're running their drills, and typically in three gun competitions, it's two shots per target, and so they're literally just double tapping.
Hmm.
And the feedback we've got from them is when they're double tapping with other brakes or with a flash hider or with no brake at all, that the double taps are the bullet impacts are 2-3 inches apart. And even on AR-10 platforms, which is the 308, they're saying double taps that are literally touching on
Hmm.
the target. So they
and
basically put it on the target and pull the trigger as fast as they can 2 times.
And that was something I noticed when I was shooting that SBR in the video. I think the very first segment I have where I'm shooting was the first time. Up until that point, I had the rifle rested, and I was making sure my zero was the same, and one thing and another, checking the functioning. So that was literally the first time that I came up on a target standing and fired two shots, and they're about 1 inch apart, dead center in the target. And I thought, wow, that was pretty impressive. And as I shoot my way through that segment, I'm shooting a little faster and a little faster. It's like I had to start learning to trust the
Yeah.
rifle to stay there, and it did. And the last two shots were very fast, and they were still, right there in that center chest area of the target. They were a little farther apart, but they stayed in that center chest area.
Oh yeah.
So I thought that was.
You can't hide from the shot timer. And that's the funny thing, because so many competitors will buy in different disciplines. They'll buy whatever everybody else tells them to buy. But one thing I can say about three gun shooters is they'll get multiple samples of a given product. They'll get this muzzle brake and that muzzle brake and this muzzle brake and that muzzle brake, and they'll go out and they'll run El Presidentes, or they'll run drills, and they're tracking their shot timers. And when when the guys that go out and they're running drills and paying attention to what the shot timer is telling them and what the target is telling them, those are the ones that consistently come back to us.
And the last thing I wanted to ask you about, the crush washer elimination system. That was something that I saw on your website. I thought that's really pretty cool, because I'm used to anytime you attach something, and as an armorer, going back to the A2 style flash suppressors and even the A1s or whatever, you always had to deal with either the crush washer or the peel washer or whatever. I
Yeah.
thought that crush washer elimination system was kind of innovative, and I'm a little surprised that we don't see more of that. Um, eh, is there anything you want to say about that? And does that give you some of that ability we were talking about a little while ago to sort of fine tune the break to the length of the barrel to get that optimum harmonic effect?
It First, to the aspect of tuning. No, it really doesn't do anything like that, and you'll understand why when I explain how the system actually works. Since you haven't actually had a chance to play with it, uh, one of the things with muzzle devices is making sure that when they're installed square to the barrel and perpendicular to the bore, or vice versa. Um, and with crush washers or jam nuts, in order that the 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 best way to make sure that you've got concentricity of the muzzle device and the barrel bore is you want the muzzle device to screw directly up against the shoulder of the barrel behind the threads. When you're dealing with, you'll see a lot of muzzle brakes that have jam nuts, so to speak. Jam nuts, if you over torque them or don't torque them, if you don't torque them properly, the muzzle brake's going to come unscrewed and you're just going to have all kinds of bad day. And if you over tighten the jam nut, it will actually cock the uh, muzzle device off from perpendicular. Uh, and then crush washers on muzzle brakes is typically not an issue unless the muzzle brake happens to be 6 inches long, because then you run into the problem of geometry. And if there's any flex in the crush washer, because crush washer is actually a flat spring, it's not actually a washer that crushes. It's just a more compact version of a Belleville spring. All it does is create tension on the threads so that the friction keeps the brake in place.
Mm-hmm.
So when you've got long muzzle devices like suppressors, or if you've got an extremely long muzzle brake, you end up with the mechanical leverage of the weight of the muzzle device, and then the distance from the muzzle to the end of the muzzle device. And if there's any flexing at all, you can run into issues where you're having baffle strikes, that type of thing. And then you've got the peel washers. Peel washers are great for making sure that everything's square, but they will make you bleed when you start peeling off those uh, 3,000 thick pieces of stainless steel. They'll slice right through your fingers. I'm sure you've experienced that.
Yeah.
So we wanted to come up with a way so that we could make sure that the brake squared to the rifle itself. And what we did is we basically made the brake in one thread pitch, which is 3/4 32, and then we use what we call a blind bushing that converts the 5/8 24 or half 28 up to 5/8 24. You've got one thread pitch on the inside and another thread pitch on the outside, and the key is to making sure that the threads per inch is different between the inside and the outside, because as an armor, I don't know if you ever worked actually in the armory where they were actually cutting threads or timing devices or anything like that.
No. No.
Typically, the way a gunsmith installs a muzzle brake, if it's going to be a permanent or semi-permanent install, they'll cut the end of the barrel with threads. They'll thread the muzzle device on, and then wherever the muzzle brake stops and is torqued to, they've got calculations that say, okay, it's this many threads per inch and it's this far, this so many degrees from level. We've got to remove this much more material from the shoulder so that it screws on farther, so that it times properly.
Right.
So what the blind bushing does on the crush washer elimination system is, instead of moving the shoulder, it allows you to move the threads. So when you're talking thread peaks versus the shoulder, you're allowed to move the threads forward instead of having to move the shoulder back.
Mm-hmm.
And then go ahead.
No, I was just going to say, I saw that in the video. I saw it on your website, and I just thought that was a very innovative attachment system. So I wanted to be sure to mention that.
Yeah, and if anybody wants to see how it works, because a lot of people, they hear it explained and they can't quite wrap their head around it. And I tell people all the time, because when you read the instructions on how to use it, it's not hard to get confused. But if you watch the 3.5 or 4 minute video under the FAQs and how to's, and you actually see me install one on the bench, and you're like, wow, that's super simple.
Well, let me jump over here. I have been completely ignoring the comment section here, so I want to jump in and see if there are any questions for you coming from the folks that are watching. And I'm just going to back up here. All of you that have been waiting, I apologize, but I've just been very much enjoying this conversation. So let me see what we might have here. And I'm just scrolling down right now. Looks like a lot of other people were just enjoying the conversation too. Here we go. Okay. Are muzzle brakes made out of different metals or one particular metal? Coming from Paul Puglia.
um, Muzzle brakes, if you're talking just as a general class of items, yeah, they're made out of all kinds of different things. Ours specifically, we use 3 different materials: the clamp-on brakes and the one we call the classic threaded brake. They're actually out of 6061 T6511 aluminum, but then they're mil spec Type 3 plus hard coated, which is basically, it turns the surface of the aluminum harder than steel. And then we use 41L steel for the black brakes, and then we use 416 stainless for our stainless brakes.
All right. And let me jump out of that one. I got another one down here as soon as I find it again. And this one was from Ray. Where'd that go? Oh, there it is. Ray Bodie asking for thoughts on linear compensators.
Linear compensators, they make a lot of noise. In some instances, they will reduce recoil slightly, but from an efficiency standpoint, compared to a true design for performance brake, they'll take the edge off of something like a 300 Win Mag, a 7 Mag, and but they're not really offering as much of a gain. Now, the one benefit they do have in hunting situations is they do strip away a ton of the gases. They're just not harnessing those gases to reduce the recoil. So you can see improvements in accuracy with a linear comp, but you're not going to see the recoil reductions.
All right. Yeah, I know those are pretty popular, and based now on what you've talked about with regard to your brakes and how they work and everything, I can see where that probably would not be nearly as efficient when it comes to, slowing down that rearward movement of the rifle. This is probably a good one to touch on. I know a lot of people are concerned with the increased noise, if you will, of the brakes. I didn't do any testing with the ones that I got from you to see, how much difference I thought there was in the sound or anything. But do you want to comment anything with regard to the louder report, I guess, that comes with the muzzle brakes?
Oh, absolutely. I, and this actually has more to do with how people phrase the question. Um, does the sound increase with a muzzle brake? Relatively or totally? No, it does not. If you if you're in a 10 by 10 room and fire a rifle with a muzzle brake and fire the same rifle without the muzzle brake, inside that room, the sound is going to be measured exactly the same. There's going to be zero difference as far as decibels. What we're dealing with is, does the sound increase relative to the shooter? So when without a muzzle brake, when all of the energy is traveling forward, the shooter isn't going to experience as much. With any muzzle brake, you're basically keeping all of that blast within a 4-foot radius of the shooter. So yeah, the shooter is going to perceive it to be much louder, even though scientifically speaking, there's no increase in decibels overall. And this is another thing with the angled baffle muzzle brakes, is because of the fact they're forcing air backwards. They are way more abusive to shooters than 90-degree baffles. And there's actually companies out there that have baffles that are actually angled slightly forward to mitigate it even more, because they're able to get enough recoil to or enough recoil mitigation to make it worth putting the brake, but it also isn't as abusive on the shooter. Me personally, I think anytime you shoot a weapon, you should be wearing earplugs if at all possible. Um, so I'm not going to say that any muzzle brake or even shooting without a muzzle brake is safe to shoot without ear pro. But yeah, some brakes are definitely way worse than others, and you'll see a lot of talk about blast shields and things like that in some threads and some forums. And yes, they do help, but it still doesn't bring down to hearing safe levels. And the most effective way to reduce the actual impact of the pressure wave to the shooter is actually to increase the diameter of the brake, so to speak, which is, if you look at the clamp on brake and then the one we call the classic threaded brake, they're actually way bigger than they need to be for being effective. But by moving the ports farther left and right, it actually creates enough of an angle that I've had a lot of people tell me, at least on a barrel that's 24 inches or longer, that they're really not noticing a huge difference with and without a brake.
Yeah, and I have not shot mine without ear protection, so
I don't
I can't
recommend
really
it.
can't really comment to that. But with the ear protection, I haven't noticed a difference in the level of sound that I'm getting
Right.
through the earmuffs or whatever.
Yeah, typically out in the open, you won't. You'll really notice it if you don't have the muzzle outside the hunting blind. If you're hunting with a muzzle brake, you'll know it then.
You touched on something a minute ago that I wanted to ask you about, and thanks, or Mr. Goldenrod. I'm going to take that off of there. With regard to the brake being level, how critical is it that your brakes are absolutely level to, I'll say, the receiver of the rifle? Is that critical, or is
Um,
it not quite so much of a concern?
it's not critical at all. Eyeball level is all it has to be. And the reason for that is, as long as the blast isn't hitting the ground, it's not going to affect the shooter one way or the other, and it's not going to affect the rifle one way or the other. You could literally mount it straight up and down if you're shooting. Say if you're shooting a discipline where you were shooting standing offhand, you could have the ports pointed up and down, and it'd make no difference
Okay.
because you'd be far enough from the ground where it wouldn't blast you.
And I also wanted to touch on something in case anybody is concerned. I talked about this in the video, but with the clamp on muzzle brakes, how much of a concern is it that those things could loosen up with time and use and eventually end up heading down range?
If you follow the directions and you maintain the muzzle brake just like you do the rest of the rifle, it's not an issue whatsoever. Uh, Typically, what we tell people as far as tightening or checking the screws for tightness, when you want to check that isn't like, say, after the first 5 or 10 shots. The first time the rifle gets hot, as far as if it shoot enough where you can't grab a hold of the barrel, let it cool down to ambient temperature, then check the screws. because at that point the barrel's going to have swelled from thermal expansion as much as it's going to, and then cooled off. So when that happens, if there's not enough dynamic stretch in the screws, that's when you'll be able to pick up that. I've got guys who have had the clamp-ons on their rifles for 13 years, and they've never moved, and they fire hundreds and thousands of rounds. So that's not really a big concern. And on occasion, the big thing I want to tell people about muzzle brakes is it's easy with a muzzle brake to forget that you've got an alignment rod in your barrel. Say if you've got a magneto speed or one of those type chronographs. We've seen a couple of pictures of muzzle brakes where they basically pulled the trigger with the little guide rod still in the barrel, and the guide rod destroys the brake. And funny enough, the brake doesn't come loose. I actually had a gentleman here recently. He had a muzzle brake on one of the clamp-ons on his 308, and he'd had it on there for 3 years, and then he went and bought I want to say it was a 358 Win Mag. And he's like, well, it's the same rifle. The barrel dimension measure is the same, but he didn't take into account the bullet diameter. So he put the brake that's rated for up to a 338 on this 358 Win Mag, and proceeded to enlarge the holes, but the brake did not move at all. So if you're not going to shoot it off that way, if it comes off, you didn't do something right.
Well, I guess that's one way to get the larger hole in there for the bigger bullet, but probably not the recommended way to go about it.
No, not at all.
All right. Anybody else? Questions, comments, anything for Jeremy while he's here? This is your chance. Any questions about muzzle brakes, how they work, what they do, what they can't do? Throw that up here. I see a lot of the questions on here. And some of these I think are just questions that were thrown out to other people that were in the chat, so not so much directed here. But I want to give everybody a chance. We've been at this for about 47 minutes. My plan is to run the show for about another 12 minutes or so, make it about an hour. So last minute questions, comments, this is the time to get them in. But I do want to take a minute too to say, Jeremy, again, thank you very much for being here.
Thanks for having me.
Yeah, I don't know about everybody else, but I just find this fascinating. This is the kind of stuff that, for me to understand better how firearms do what they do, how to improve the way they do what they do, how to get greater stability in a bullet, better barrel harmonics, all that kind of thing. That's, very, very interesting to me. And I hope that everybody else watching out there feels the same way.
Yeah.
It's just, go ahead, please.
Well, I was just going to say, for all the viewers that are out there, and you can appreciate where this code comes from, being a Marine. But if you use the coupon code 8541, it'll give you 10% off your order. And I guess you can tell them where the 8541 comes from.
That's the MOS designation for a Marine Corps sniper.
Yeah, but before they changed it to the 0311s and that type of thing.
Right.
The old designation.
Yeah, and that's one of the things I don't understand is that whatever they've done with the Marine Corps Scout Sniper program, it's now been divided up, and I don't even know what they're doing. They're doing a complete restructuring of the Marine Corps, it seems like, and a lot of what we've seen for a long time is ceasing to exist in the form that we've known it and taking on some new form. So I don't know. I hope it works well, but I hate to see some of those older, I say older, those traditional designations go away. My old MOS, 5811, which is military police, is being phased out. In fact, I'm not sure just how many MPs are still left in the Marine Corps right this moment. So it's just, Yeah, don't they've gotten rid of the tanks. Marines aren't going to have their own tanks. They're going to be relying on the Army these days. So a lot of things going by the wayside that have been fixtures in the Marine Corps for a long time,
Yeah.
which is odd because the Marine Corps typically changes about as often as the Ice Age comes around, or and I'm not seeing. Oh, Love's Dog 1954 just talking about people need to shore patrol us. I'm not even sure what he's getting at with that, but knowing him, he'll get a hold of me later and tell me all about it. But any last minute things you want to get in, Jeremy? Anything that I didn't cover that you think you want to get out there to everybody, or any new products that you're working on? I know also on your website you make bipod attachments or
Yeah.
leg attachments.
That is something we launched those. It's probably been 9 or 10 years ago. I personally have always been a big fan of the old school Harris bipods.
Mhm.
But one thing I found frustrating when I started getting into competition shooting was the inability to change the style of feet on the bipods. So we came out with uh, the pod mod adapters, which basically you remove the El Cheapo plastic little feet off of the Harris bipod or any Harris clone, as long as the leg's a 3/8 diameter leg, and then you install the pod mod, and then it allows you to use any foot style bipod foot that would work on the Atlas bipods. And if you're familiar with those, they're really nice bipods, and they serve certain disciplines very well. But in some of the faster moving competitions, they're not as quick to adapt to different situations. Say during a shooting stage where you've got to go from prone to shooting off the hood of a car, that type of thing.
Mhm.
Uh, so using the pod mod adapters, it allows you the option of using rubber feet, spike feet. You can run something like a Hawk Hill Talon. You can use like the little ski feet, like you'll see a lot of F class shooters run. That allows the bipod to slide backwards so that you're maintaining a linear movement of the rifle, and it allows you to change the feet in 30 seconds or less. It's just a little detent ball that you press in and swap your feet out.
Yeah, and that's cool. I have a lot lot of rounds fired over those old Harris bipods, and I always just use the rubber feet. So I might have to try out some of yours sometime just to see how much a difference that makes, or if I
Oh
can
yeah,
notice a difference.
yeah. The biggest place you're going to see a difference is if you're shooting off of like a wooden barricade or something like that, and you're not going to get the bounce, or say you're shooting off of a rooftop, and you know those for law enforcement snipers. Sitting up on a rooftop, then those rubber feet, even though they're rubber, are not real grippy and can slide and cause you to lose position. Whereas the rubber feet that you can get for the Atlases, they're a very grippy rubber. So when you set the rifle down, it's not going to slide like it will on the Harris plastic feet.
And I can tell you where I noticed that bounce the most, and this goes back a number of years. I went to a sniper school that was conducted up at Camp Perry, and for a portion of that school, we were shooting in the trying to think what the name of the range is that's actually covered. It's almost like you're inside of a building, but they have the big garage doors that open up. And we were shooting off the concrete floor there. And I can remember, I was used to shooting just with the bipod resting on the ground, so I didn't get a lot of bounce. But off of that concrete, holy smokes, everything was moving. The first time I shot a couple of shots, I thought, holy smokes.
Yeah.
And then I finally
Yeah.
got to where I was loading a little bit better and controlling it a little bit
Yeah.
better. That's a place where I wish I had the muzzle brake attached.
Yeah. And I'm glad we started talking about this because it forgot to cover something that's really important, and that's question we get all of the time. In fact, it's even one of the FAQs on our website is why don't we use ports on the top to keep the muzzle down? And this goes back to just general recoil science altogether. When you pull the trigger and the gun starts moving backwards, it's coming in a straight line. The muzzle does not rise automatically. What causes the muzzle to rise or the muzzle to jump is the gun is moving straight back in a straight line, perpendicular to or in line with the bore. There's one problem: your shoulder's in the way.
Hmm.
Well, because the bore line is above your shoulder, it's going to go up. It's going to try and rotate around your shoulder. So that's one of the things we cover on our website in a blog posting and an article that we share frequently on Facebook and other places is the difference between muzzle brakes and compensators. A compensator basically steers the muzzle. So basically, yeah, it will keep the muzzle down, but depending on whether you're shooting free offhand or off of a barricade or things like that, a compensator can actually overcompensate and actually push you down off the target instead of keeping you on target. But what we've found is that the more efficient or the more effective a brake is at stopping the recoil, which is actually the website name, stoprecoil.com, is the easiest way to find us, is if you stop that motion coming back to your shoulder, then there's no energy left to cause the rifle to uh, rise up. So if you concentrate on making a muzzle brake that does what it's supposed to do, you don't have to have the ports on the top because the muzzle's not going to try and rise because the rearward momentum was already arrested.
And that seems to be exactly what I've seen with my rifles, because that's the movement that I would get under recoil is the rifle would be moving up, and then I would have to reacquire my sight picture. Whereas now,
Right.
as I said before, it stays much more stable, and I'm able to see essentially where the bullet is impacting.
Oh, yeah.
So, all right. Well, Jeremy, this has been tremendous. If you would do me a favor, I'm going to move you out of the room just while I wrap things up here, but don't go away.
All right.
And I will be back just in a couple of moments here. And for all of you that have been watching, thank you very much. I hope you enjoyed this as much as I do, or as much as I did, rather. I appreciate all of you watching. I appreciate the comments. Thanks to everyone who watched the video this morning. Uh, as always, I tell people all the time, I have the best viewers on the internet. I have the best viewers in the world, and that includes all of you. So thank you very much. Have a great day. Enjoy the rest of the week. I hope to see you all on Saturdays. And as always, a special shout out to my channel members. Thank you. Thank you for the contribution you make every month. I could not do everything I do without that. So everyone take care, and I am going to see you next time. Good shooting for now, and bye-bye.